All right, Algebra 1. So today on Monday, we are going to be starting our next unit, which is going to be about graphing quadratics. You've already done one page of notes on this about the characteristics. We're going to continue that today with how do you identify what is a quadratic and what is not a quadratic. Um, so with that being said, section 11.1, which we're going over today, that practice is going to be due on Tuesday of this week, and that's going to be April the 16th. So vertex form is what we're going to talk about on Tuesday. That will be due on block day, which will be Thursday, April the 18th. And then section 11.3, which is transformations, that will be due on, we're going to be covering that on Thursday. So that will be due on Monday when we come back, since we do not have school on Friday. So that will be Monday, and that's going to be April the 22nd. The rest of the due dates we'll fill out when I get back on Tuesday. But there's kind of your idea of what we're going to start off with. So 11.1, identifying quadratics. First, let's talk about what a quadratic function is. It is a polynomial with a degree of 2, meaning that the highest exponent that you see is the number 2. And so remember, degree would be exponent. So if you want to make a note to yourself there, degree would be your exponent. So it's a type of polynomial with a degree of 2. So what we're going to do is we're going to compare linear to quadratic functions, starting by kind of looking at their tables. So I've got a linear function here, y equals 2x plus 1, which means if I put 0 in for x, I get 2 multiplied by 0 plus 1, and then you could type that into your calculator. You will get an answer of 1. And then if I wanted to do the number 1, I'd put 1 into it, so 2 multiplied by 1 plus 1. So in other words, each of these numbers, 0, 1, 2, 3, 4, I am just putting in for x and then putting it into a calculator. So for this one, 2 multiplied by 1 is 2, plus 1 is 3. And then if you do the same thing with the number 2, you'll get the number 5 out, and then 7, and then 9. Quadratics, a little bit different, still work the same way. So if I put 0 in for x, I'd have 0 squared plus 1. Notice that when you're squaring something, put it into parentheses. That way you type it into your calculator correctly. It will also start at 1 because 0 squared is 0 plus 1 is 1. If you put in the number 1, though, you get 1 squared plus 1, which 1 squared is 1 plus 1 is 2. And then if you put in 2, you'll get an answer of 5. If you put in 3, you'll get an answer of 10. And if you put in 4, you'll get an answer of 17. So how do you identify them from a table? Linear functions are going to have what's called a common first difference, whereas quadratic functions are going to have a common second difference. And so we're going to look at a couple examples of that with examples A and B here. So example A, let's look at what the common difference is. So to get from 0 to 1, we go up by 1. To go from 1 to 4, we go up by 3. From 4 to 9, we go up by 5. And 9 to 16, up by 7. So notice that we're not going up by the same number each time. But if you look at those numbers that we just found, from 1 to 3, you go up by 2. 3 to 5, go up by 2. 5 to 7, up by 2. In other words, there's a second common difference. That's what we meant by a second common difference. And so what that would mean is that example A is in fact a quadratic function. And as far as explaining why, that's where you're showing your work. Okay, so in B, let's take a look at it. So from 8 to 2, we would go down by 6, so we'll write that as a negative 6. 2 to 0, we'd go down by 2, so we'll write that as a negative 2. And then from 0 to 2, we go up by 2. And 2 to 8, we go up by 6. So again, not a first common difference. But from negative 6 to negative 2, we'd go up by 4. Negative 2 to positive 2, up by 4. 2 to 6, up by 4. Again, you've got a second common difference. So B is also a quadratic function. Okay, so looking at C, you've got an equation, y equals negative 3x plus 20. Look at what the exponent is for your variable. It's got an exponent of 1. That's going to tell you that this is a linear function. And your explanation would be an exponent or a degree is equal to 1. For D, y plus 3x squared equals negative 4. You look at where x is, you look at its exponent, which is 2. Now you do have a quadratic function because that highest exponent that you see is 2. And so your explanation would be that the degree equals 2. For E and F, let's take a look at those next. So similar to a table, we're going to look at the y values. Notice that they're written as points. So from 4 to 1, we would go down by 3. From 1 to 0, we'd go down by 1. 0 to 1, up by 1. 1 to 4, up by 3. So no difference this first time. From -3 to -1, though, go up by 2. -1 to 1, up by 2. 1 to 3, up by 2. There's your explanation, and you can just say that it's quadratic. All right, one more example to look at. So from 9 to 2, we'd go down by 7. 2 to -1, down by 3. -1 to 0, up by 1. And then 0 to 7, up by 7. And then let's check and see from -7 up to -3, we'd be going up by 4. From -3 to 1, we'd also be going up by 4. And then from 1 to 7, we're going up by 6. So we don't have a second common difference this time, so this is not quadratic. And then your explanation is you showed your work. Okay, let's look at the graphs and let's kind of see how you'd graph it from a table. So the first thing you'd have to do is fill in your table, which would mean putting each of these into your calculator. So take -2 and put it into your equation. So you would say -2 squared. Please be sure you're using parentheses. The answer here is 4. And then you type in -1 squared, and you'd get a +1. You'd put 0 in, squared is 0, 1 squared is 1, 2 squared is 4. And so when you graph each of those points, -2 comma 4 would be right here. Here's -1 +1, 0 0, 1 comma 1, 2 comma 4. And then if you notice, here is what the graph is going to look like. Very similar to those graphs that we were looking at last week. And there's where your graph would be. Now this second graph is a little bit different. Notice that it says y equals -x squared as opposed to +x squared, which means when you type it into your calculator, you need to put a negative in front of the parentheses and write it like this: negative parentheses, -2 parentheses squared. The answer here does in fact end up being -4. So then when you put in -1, you'd say negative parentheses, -1 squared. You're going to get -1 as your answer. 0 is still going to be 0, and then you're going to have -1 and -4 for the rest of your y values. So graphing these points, -2, -4 would be right here. -1, -1, 0, 0, 1, -1, and 2, -4. Here would be your points. We would then connect those to make our graph, which would look basically the same way. Notice that when you put a negative in front, though, it makes your graph open down. If you remember what we called that concave down versus concave up for the first one. All right, guys, that's it for our notes today. As soon as you've filled these out, make sure you show them to the sub. She will give you your homework. Your homework is worksheet 11.1. It is over identifying quadratic functions. It will be very similar to what you saw in the notes just now. That is due tomorrow. We'll go over any questions. There is an answer key on Schoology for you guys to check your work. And I will see you on Tuesday. Have a good rest of your Monday.